Well, hello everyone, and welcome to today's webinar on an assessment of lightweight secondary windows. Before we get started, I'm going to review just a few webinar logistics. Today's webinar is based on an evaluation by the National Renewable Energy Laboratory, and you can find the full report as well as summary documents on gsa.gov. And we'll also be posting links to that project page in the Zoom chat window. Today's webinar, you'll be in listen-only mode, and you can submit questions by using the Q&A button on the bottom of your screen. And you don't need to wait until the end of the presentations to submit your questions. In fact, we encourage you to submit questions well in advance of the Q&A session. Today's webinar is being recorded and will be shared with you. And you can find the presentation slides and recordings for all past webinars on our webinar page at gsa.gov. And you can also access all webinar recordings on our YouTube channel. And we'll also be posting those links there in the chat window. And with that, I'd like to turn it over to the Director of the Center for Emerging Building Technologies, Kevin Powell.
Thank you, Andrea. And I want to thank everybody out there for joining us today. We're very excited to share results from this study. Spoiler alert, this technology performed well. We think it will represent a key tool in our net zero building tool belt. In terms of our agenda, I'm going to offer some brief opening remarks to put this technology in broader context. Our PI will then present a more detailed account of the results from our field study and an analysis of the potential for broader deployment. And we'll then hear from our GPG regional program manager, who will offer a boots on the ground perspective. And most importantly, we'll spend some time answering your questions, which, as Andrea says, you need to put into the chat. Next slide. So relative to essentially, well, Windows in particular, there really have been many technologies over the past couple of decades that improve facility operations, particularly in the area of HVAC and controls, lighting as well, of course. There really hasn't been a whole lot of innovation in terms of envelope performance. I think we could safely say that in 1991, so really 30 plus years ago, double pane windows were the state of the art in the US, and they still are, really. So there's a lot of opportunity to improve building envelope performance and windows in particular. Next slide. And that really brings us to what we're here to talk about today. There have been significant advances in the commercialization of thin glass as a result of the proliferation of the ubiquitous smartphone, flat panel TVs. And last month, we presented results from the application of that technology to high performance, newer replacement windows. In this webinar, we're going to present an application of this technology as a retrofit solution where window replacements are too costly. Next slide. So let me turn this over to Kasal Kiat-Ringwatana, who is our principal investigator from NREL and led evaluation of this technology. Kasal?
Thank you, Kevin. All right. Good morning, everyone. Again, my name is Kasal Kiat-Ringwatana. I'm a researcher, a senior engineer at the National Renewable Energy Laboratory. So talk a little bit about NREL. NREL is one of the 17 Department of Energy national laboratory systems, but we are the only national lab that focus on the energy efficiency and renewable energy area. I've been with NREL, leading and supporting NREL government agencies on the energy efficiency and renewable energy projects and programs. This is my 13 years at NREL. Before that, I was working for a consulting firm, working in various roles for the projects in the high performance buildings areas, energy assessments, modeling, and then also building energy commissioning. I am also a professional engineer registered in state of Colorado, certified energy manager, and also a lead accredited professional. So today I will be presenting a summary of our findings on our research work for this projects, technology demonstration and validation of the secondary windows technology. Next slide, please. So for the what is the lightweight? What is the secondary windows? A lot of people might be familiar with the name. There's a different names of these secondary window, including window insert, right? Or a storm window. But this is the interior storm window. A typical storm window will install outside of the existing window, but this is this application is will be installed inside of the building. So so what is make it lightweight? Like Kevin just mentioned, with the more application and popularity of using the thin glass, to the electronics world, it's becoming more popular also into the window manufacturing. So the thin glass is basically 2 or 3 times lighter than a standard glass. So it would be a good, once it put together as a unit, it's a good application to add into existing structures that may be sensitive to weight, right? And it's one of the benefit is very easy to install, no drilling, no permanent device, easy to install and also remove. And it's worked really, really well with the any building, as Kevin mentioned about like maybe a cost prohibited in terms of like the builder replacement, but also like some limitation that's maybe from the aesthetics limitation, such as the historic building that you cannot make any change from the for the exterior buildings. So this is going to be a good application for. Next slide, please. So there are 2 configuration of these secondary windows. One is a single pane and a double pane. They all come with the insulated fiberglass frames. So make it superior in terms of the thermal performance. At this, you can see that on the left-hand side, this is the single pane, and then on the right-hand side is double pane. So it depends on the size, depends on the applications. You can see that why the thickness is different between the single pane and then the double pane. So it's depend on the application and the size. Like I mentioned, that sometimes like they might have to making the thin glass is slightly thicker, but it's still like is within the thin glass specifications. To make sure that the structure integrity of like the windows is appropriate for the window application. Next slide, please. So this is we're going to talk a little bit more on this once like we dive into the our findings, but this is a kind of high level in terms of performance. You can see that when we talk about the thermal performance, which is a U factor or U values of the windows. For the single pane, approximately under R1. And once we include this improving with these secondary windows, it's basically double or even quadruple the performance of these single pane windows. Next slide, please. So a little bit in more detail of comparisons between these single pane and double pane secondary windows. the cost is approximately, this is the install cost, first install cost, first cost. So approximately $5 difference between these two technologies. And then definitely the weight increasing, but still like, significantly lower compared to like, still like for the double pane secondary, still even less than half of the standard double pane windows in terms of weight. And the condensation resistance is, it could significantly improve this condensation resistance. It's particularly with the building in the cold climate locations, cold and humid, often may experience the condensation happenings on the windows. So this technology will help improving these condensations resistant to the existing windows, as well as the air leakage. So, a lot of the single pane windows experience a high air leakage, building tightness, and so it's significantly reduced. We're going to go to in more detail of this air leakage as well. So next slide, please. So again, this is the summary of the findings of our research work of these monitoring and verifications work that we conducted at the Denver Federal Center. This is one of the GSA facilities. Is at the Building 53. The Building 53 was built in the 1960s, of course, with the single pane windows everywhere. It's a two-story buildings, consists of offices, conference, training space, like industrial laboratories, and as well as warehouses. So we're going to talk about it, the size implication and how lightweight. So that the ladies from the left-hand side, this is this is not the size that we install. It's even much bigger windows size than she comfortably can handle and hold that secondary window. So it's really lightweight. Next slide, please. So on the M&V design, we install the secondary windows, 10 windows on the one of the wing of the Building 53, total of 10 secondary windows, 5 in the enclosed buildings and 5 in the open office. Each office will have a combination of both single pane and double pane windows. So we install numbers of monitoring sensors, measure glass temperature, frame surfaces, space conditions, and use those field data to calibrate our model. The model was created in the DOE Windows and Therm software. And these two primary software often used for calculate the thermal performance rating of any windows or any window attachment. So the result is the thermal performance indices that, with the calibrate model and with the measured data. And then we use this kind of performance index, and then a model is in the Energy Plus, the whole building energy simulations. This is going to be a sort of a techno-economic analysis for the to evaluate this technology and we conducted in the large and medium office buildings model using the DOE commercial reference buildings model. And we calculate various of the energy savings, HVAC capacity reductions, as well as the economic of the technology. Next slide, please. So this is the a simulated model result. So this is just only the window and therm models. Again, people who are pretty familiar with the windows, you can put a lot of configurations and then of the Windows assembly, and you will get with the appropriate boundary conditions, you will get the performance of these windows. For the therm simulation, this is the two-dimensional heat transfer. Basically, you can see the heat transfer, the temperature gradients from the boundary that was setting. We're looking at, we're comparing with the actual field data, and then the predicted temperatures from various locations that match the monitoring. So the results, as I mentioned, like, it's the U values, solar heat gain coefficients, visible transmission, and also the condensation rating. It's definitely showing a significantly improve on the thermal performance of the existing windows. Next slide, please. So the another side benefits of this thermal performance energy saving is an increased thermal comfort. So we have monitored the temperatures and see that's how improved from the with the existing single pane window, and then the window with the secondary windows. So the data on the right hand side is showing like during the cold day, outside temperatures are pretty very cold day. You can see that the surface temperature of the windows significantly improved by at least 20 degrees. So definitely creating a warm surfaces and improve a lot of thermal comfort to the occupant. People who are pretty familiar with sitting or working near the window, we often feel cold. We call it, the effect of, like, they might call it drafty windows. Sitting, it's a lot of effect of, heat loss from our body to the cold surface temperatures, and then the convective heat transfer that happening near the windows. So with this technology, will significantly improve this thermal comfort. And of course, we conducted the thermal comfort analysis using the University of Berkeley thermal comfort tool, CBE thermal comfort tools, and conduct the thermal comfort. This is the per ASHRAE 55 thermal comfort batteries. The results showing the majority of the conditions are within the comfort boundary. So that's a good result. And again, the detail of this analysis and study can be found in more detail in the report. Next slide, please. So for the condensations, as I mentioned, that it significantly improves the condensation resistance. The existing windows, we estimate at the 12 CR condensation ratings. And then with this, the combination of these single pane and double pane windows significantly improve up to 44 to 46 CR. Next slide, please. Impact of air infiltration. This is additional benefits. DOE estimates that the heat loss due to the air leakage, it's accounting for, like, even 20% of the building use through the building envelope, right? The data on the right hand side, it's showing like the higher the infiltration, definitely the heat loss that you will get, and also at the colder climate, at the same heat air infiltrations, the more heat loss you will get for the colder climate, right? So definitely reducing air infiltration, improve air tightness will save you a lot of energy use. Next slide, please. So the air infiltration or air tightness is somehow this is not a part of our study, but we want to presenting the an independent studies that showing, and also like the AERC people but who are familiar with a lot of the standards might be familiar with NFRC fenestrations rating, right? So NFRC basically is the fenestration rating for windows, and AERC rating is definitely it's for the any window attachment. So a slightly different, but a lot of the time like going through stringent, like a way to estimate and then the rating any window and window products. So AERC estimate that an average air infiltration for a single pane window is approximately 2 CFM. I'm sorry for that small typo. 2 CFM per square foot, and then with the Energy Star storm windows, the leakage is requires to be lower than 0.5 CFM per square foot. But with this independent study showing that this both secondary and both single pane and the double pane secondary window have the air infiltrations approximately 0.06 CFM per square feet. So it significantly reduced the air infiltration to the buildings. Next slide, please. So this is another additional benefits besides the energy savings that you will get if the work is done and then later on or at the same time you have the happen to have the HVAC improvements or replacement as well. This is additional benefits that you may get from the HVAC capacity reductions. From this study, we estimate that for the medium office, the HVAC capacities can be reduced from 13 to 19% for cooling and heating, or approximately $8,500 per year over the 20 years over the life of the HVAC. Next slide, please. And and this is the energy savings, and then the economics when we did analysis. Again, we did both analysis for medium and large office. So this is the results as example for the medium office. We can see that the this analysis is based on the first cost of the system, means like you're buying a new one and put it in. It's not an incremental cost of anything, but the payback is still in very favorable payback. Paybacks is under 10 years paybacks, and saving is approximately 15%. And this estimate not even include any additional HVAC capacity reduction, as I mentioned. It's just only energy savings, and also like the air tightness or air infiltration improvement we not include in this analysis. Still giving a very, very good economic. Next slide, please. So we also did additional analysis or studies to whether the single pane and double pane, how they perform in the warmer climate with customized solar heat gain coefficient. The result is find out that very interesting that actually for the warmer climate, you don't need a super insulated, as we all know, like it's a similar concept as you probably don't need a triple or quad pane for the warmer climate, because a lot of the time the solar control is it's very important. Shading coefficient, or like solar control or solar heat gain coefficient, this kind of term, it's more important. And with this analysis, it's showing that actually the single pane secondary have a better payback in the warmer climate with the solar control. Next slide, please. So in summaries, for these studies, as we mentioned, that the energy savings is between 11 to 18% savings. This is for a medium-sized office. This is across the climate zones. And reducing air infiltration is added benefits, particularly for the cold climates. And it's definitely improved the thermal comforts, the surface temperatures, window surface temperatures improve up to 20 degrees, as well as it's improved the window condensation resistance to the existing single pane window. In terms of cost effectiveness, the payback is between 6 to 11 years. As we mentioned that the any improvements, any work, it's quite specific to the buildings and then the climate zone. So we encourage the further detail study for your buildings. But this analysis and the results are supposed to provide a guideline and then maybe for you new consideration of this technology for your projects in the future. But again, it's highly specific to the site. So we encourage a detailed study when you're doing the study. So that's for my presentation. So I'll give it to next section to Tyler Cooper for GSA. Thank you.
Thanks, Kasal. So yes, I'm Tyler Cooper, mechanical engineer here in Region 8 for GSA. I'm going to go over on-the-ground feedback, general installation of the window inserts, and feedback from the occupants. So next slide. Big thing with these is easy installation process. On general, assuming everything sized correctly, we'd estimate about a minute per person for one window to install. If there's other issues with sizing, that can increase. So conservatively, we estimate about $1.15 per square foot on installation cost, which assuming 15 minutes per window, just for cost estimating purposes. Big thing with these, you have no drilled holes or permanent devices that are needed to fix the windows, which we will go over a video here that shows the installation of these. So you can see here, we're on the interior of the building, and they're essentially just going to drop right into the existing window space. What we're looking for is a full suction around that window into the space. And you see there, that's all it takes, where we're done in 10 seconds with that installation. We'll watch that one more time too, if anyone's curious. So that is the extent of the installation process. Next slide, I'll go over some of the challenges that we did face with these. So for the where we installed these at Building 53, the existing structure was concrete and brick walls built in the 1940s. So we had experienced settling of the windows. They weren't square. So as part of the installation process with these, we went through and took measurements of every window in the area that we were replacing. As noted, a lot of these weren't square. So as part of that process, to ensure we've got that proper seal around the windows, we modified the gasketing on each of those inserts. There's a default size, so we were able to remove the existing gasketing on those, go to a thicker gasket in places where we didn't have a perfect fit around the windows. This allowed us to get that air sealage that we were looking for, making sure that they were fitting properly in the windows and getting that seal that we're looking for. There is the option to add additional safety fasteners. They're not necessary, but we did add a couple of these, pretty much just a small little bracket that you can attach into the existing wall. Any fastener would do, and that just makes sure that any settling these wouldn't fall out. But in general, the windows will sit perfectly in the existing window without any need for attachments there. Next slide. So this is just a basic suction tool. As you saw with the installation, once we're getting in there, because of the gasketing around there, you do have a pretty tight seal with the window. So what we used for removal of these is a suction tool like this, facilitates the removal and cleaning. Without that, you have no means to grip onto the window. So this gives you means to pull it out. Obviously, the cleaning frequency is going to depend on the condition of the existing single pane windows that we are retrofitting these onto, the amount of leakage that is taking place there. But with that said, the installation that you saw is about 10-15 seconds. So with that, they remove just as easily if situations arise where we do need to go through and clean between those two windows. Next slide. So in terms of occupant satisfaction, we had that 60% of our occupants in the space were satisfied. We noted that there was some thermal discomfort, but that was due to the existing HVAC in the space. As Casal mentioned, most of the thermal radiation coming off the windows, the cold factor, draftiness was significantly reduced as a result of that. You can notice the window inserts on the inside of the building, but they do provide a clear opening to the outside space. And along with that, unless you're using specific films, you are still going to have glare happening similar to what would happen previously. But that's going to be the case with any window installation. Next slide. So best practices, as mentioned, going to the higher efficiency windows, we can, as part of a whole building envelope retrofit, we can reduce the size of our HVAC capacity requirements. So when we have the opportunity to combine these projects with additional HVAC projects, we can right size the mechanical equipment, making sure that we're downsizing that and see additional energy savings beyond what we're seeing from the reduced energy loss at the windows. The configuration should be customized for different climates. Of note is the solar heat gain coefficient that Saul mentioned, allow us to reduce that solar heat gain in those warmer climates, where it is more beneficial in the colder climates during the winter months. With that said, recommend the high solar gain heat coefficient. Probably recommend that for heating dominated climates. Want to make sure we are maintaining that in those buildings. And conversely, we want to block that heat gain and have a low solar heat gain coefficient in those cooling dominated climates. Next slide. So in terms of our deployment recommendation, cold climates, we'd recommend the double pane secondary windows with high solar heat gain. That's going to be the most cost effective. Warmer climates, as mentioned, that single pane insert with low solar heat gain coefficient, that has a better return on investment. These are better suited for, they are well suited for historic buildings where changes to the external facade are limited. As mentioned, site-specific evaluation is going to be helpful in gauging the success of these window retrofits. On average, we estimate probably about a 20-year lifespan for these window inserts. So, and going through and making those project decisions, it's helpful to go through, look at what your expected lifespan is for that, what the condition of those existing single pane windows are, and if it is going to make sense to add these window inserts versus going to a full scale window retrofit and upgrading to double, triple, or quad pane windows as part of that process to increase that overall performance of the envelope. And that should all be evaluated. So with that, we'll kick it off to the Q&A.
Great, thanks. So we have a bunch of questions. We'll try and get through as many of these as we can. And if we aren't able to answer your question, we'll also be following up. So first, we have a number of questions about whether these windows stay operable after the installation of the secondary window.
I'll answer that question. For this, because of the nature, because of the existing window, the single pane itself is not operable. And this is like the application that we are testing. It's basically improving the existing fixed window. So this is not the operable windows that we use. But again, if the existing is operable, again, it doesn't mean that we can put it into any operable window, but it's by itself is not operable. So.
And do we know the largest window size that these inserts apply to?
We don't have that information, but as you've seen in the pictures, it looks like the one that we are testing is, I believe, is 7 by 5, 7 feet by 5 feet. And then the one in the picture, you can see that it's definitely big size. It's like probably at least, 5 to 7 feet. It's very similar, but even bigger than what we are testing.
Okay, and we'll get back to you with a more specific on those size limitations.
Yeah, but we expect you. We also like recommended with consulting with the manufacturer. Yeah, I think they'll probably have more information on that. Sorry. Yeah.
I believe we'll follow up on this too. I believe if you did have a larger, you can essentially combine 2 sets of windows there and then put a divider between that to work with the larger opening. And
Okay.
we'll follow up on that too.
That's a really good point. Yeah.
So prior experience with interior storm windows has found that the moisture can be trapped between the original single pane and the interior storm, creating problems like rot. How does this solution address that problem?
Yeah, I would say that from the results, it significantly cut the air infiltration. So number one is like you will have a less impact on the air infiltration, coming to the building, to the building, as well as the improved surface temperatures. Often it's like condensation happening when the surface is very, very cold. So it's unlikely it's gonna happen with the surface, inner surface of the secondary window itself, because it's a warmer surface temperatures. But the surface in between the existing single pane and then the secondary windows, those we don't know. Number one is like we didn't experience any problem like that. And number two is like because of the space in between the existing single pane and then the double pane, the gap is very small. We're talking about the amount of moisture in that gap. It's very, very small. So again, we don't have that data for now, but it's unlikely it's going to happen.
Great. Thank you, Kasal. So how would this work, this secondary windows work if you have existing security or blast film on the existing windows? Is there any impact on blast film performance?
No, again, this is nothing. There's no changes to the existing windows. So I don't expect any impact or any changes to the existing, whether it's gonna be blast resistant or just a typical Windows. There shouldn't be any impact.
Great. Do we know what holds the thin glass in place?
That's a secret. I'm sorry. No, no. Definitely there's a specific adhesive that's that's used in the window industry. I know that's that manufacturers like talking about even the high performance adhesive. They and these windows they've been tested in terms of durability and longevity. So yeah, it's a special chemical adhesive. That's all I can say.
And do we know if the thin glass is more prone to breakage from impacts, like maintenance bumping into it while cleaning?
That's a good point. That's a good question. It's possible because of the nature of the thin glass itself. So, but however, during our study, we remove, we didn't have any problem with that. So again, this is because of glass and windows. Gotta be do it gently, right? And then be careful on that one. But we didn't experience during the removal of these units during the study.
Okay. And we had a number of questions about how these attach. So Tyler, Kasal, can you talk a little bit more about how these attached, whether it was magnets or what actually holds them in place?
Okay, I'll speak a little bit, and then Tyler, maybe you can chime in as well. So in general, they have a specific, special seal around the secondary window. Once you put it in, it's sealed around the edge, of these windows, and there's no adhesive or any specific attachment on that one, because once you push it in, it's already creating a suction that's holding the window by itself already. That's why we need a suction cup when we want to remove it. Tyler, you have anything to add? Sorry.
Yeah, and I guess that's what I'm referring. I don't know this, but I was referring that to as the gasket. But yeah, it's a seal specific to those windows, and then that'll be sized according to ideally that'll be sized according to the opening in the window, so we get that proper suction.
So we did have a comment that inserts were installed at a historic building in Baltimore. I don't think they weren't the same inserts. They weren't these lightweight thin glass inserts. They're the previous version of inserts that we tested. There was an issue, it sounds like, with things falling off. But do you know, I don't know if you can say anything, either Kevin or Tyler, about that installation and also in regards to this technology?
I'll take the first crack and say that we need to research what that, or sort of reach back and see what that what specific insert was put into place. I don't think it was this one. It does raise a question that actually maybe Kasal, you could answer, or Tyler, which is if you have a very leaky exterior window and then you put these in place, does that put additional stress, I guess, on that gasket or attachment? And it sounds to me like the one that was in Baltimore had some real issues with that attachment piece. And I understand the attachment is proprietary, but any thoughts on that? And probably Kasal, you'd be the best person to answer that.
Yeah, thank you. Again, don't know much about the detail of that study and what's happened, what's the technology, but very likely I would guess that maybe the seal or the gasket maybe not tightly installed. That's probably a potential problem. But again, with a question that Kevin asked, that what's happened with the leaky single pane window, I would say that, of course, there's gonna be air movement between the existing single pane and then the window, secondary window or window insert. But I don't anticipate that it's gonna be the wind effect or the blown in is going to be enough to blow in the secondary window off with the gasket that we put it in there. So I don't know again, I don't know the results or the detail of that previous study, but with this one, I don't anticipate that problem.
Great. Anything else from you, Tyler, on that one?
Oh, I think like I mentioned, essentially, like if there are concerns beyond the seal of the steel on the window, we did do a couple test installations of brackets, and really that was all the external support we needed, with just one small bracket into the wall surrounding the insert, and that was enough to provide that additional security for the window if there were concerns about that falling out. But in general, we had no issues with that, and that was more of a precautionary measure.
Great, thank you. Do these secondary windows help with sound attenuation from exterior noise? Would you expect it to block noise?
We didn't test the noise level. However, I'm very positive that would significantly improve with the seal around the windows, the almost adding another additional double pane to the existing. I anticipating a significant noise reduction.
Great.
So, yeah.
What type of frame do these inserts have?
This is a fiberglass frame. So as we all know, that's fiberglass providing a superior thermal performance when compared to other type of frames.
Do you have any experience or thoughts on applying these inserts to existing windows that are already double glazed?
I think number one is when we talk about double glaze existing, because of the technologies has been in terms of double pane itself, double glaze itself, it's been a while, and it's depending on the conditions and quality and everything. Of course, would be a good candidate not only just for the existing single pane, but an old double pane, non-performing double pane as well. So
great. Is the secondary glass laminated glass?
It could, if you're looking at the detail for this particular manufacturer with the a single pane unit that they have. Somehow with the single pane, they're using a very, very thin glass. That one they are using films. And then with the double pane, there's an options on the thicker thin glass. They can laminate. Yep, they can put the laminate on the solar control in there. So.
And another question on the glass: how thick is the glass, or thin? And is it tempered? Or can it be tempered? Yeah.
In general, when we talk about the definition of the thin glass could be 3/4 of a millimeters to up to like 1.3 millimeters. So it depends on the thickness, right? So 0.75 to 1.3, and when compared to a standard glass for the windows widely ranging from the size as well, but a smaller standard, it could be up to 3 millimeters. So we'll talk about that. So it's significantly thinner.
And would you recommend these windows with hurricane-proof windows? Would there be any impact there?
I'm sorry, I think my connection is okay. Can you hear me right?
Yes, yeah. Now we can.
Yeah, I think for the hurricanes location, again, because of this one is installed inside in interior installations. I think the problem that you're gonna get is probably for the exterior existing one. Of course, it's not by the standard of this unit that's come from the manufacturer. It's not a blast resistance, but talk to the manufacturers, that could be an option, but right now with the existing the product that they are pushing for now is for a broader application, not necessarily considered as a blast resistant, but I'm sure that the industry move towards that kind of option as well in the future.
Can secondary windows or these secondary windows be used seasonally for operable windows in cold climates? Would that be recommended? Tyler, you might also be able to speak to that.
I'll start with me first.
Okay.
Yeah, of course, like, particularly with the, I would call like, any mixed mild climate, from the results that we are showing that, climate zone like 4 or 5, it's working very well that when you have also pretty decent winter, also in the warm climate, you still have a pretty warm climate. So during a shorter season, you can experience like, breeze or any natural ventilation that you can get through the windows. So of course, like, I would suggest if it's applied to your buildings, definitely take advantage of like natural ventilation for those any existing operable windows by either remove or install this secondary window as needed.
Tyler, any additional thoughts on that question?
I think I pretty much concur with Gasol. Obviously, big thing if you are removing them, you need a spot for storage and safely store those during off period times. But yeah, if you're able to take advantage of the natural ventilation during those off season time periods, then that makes perfect sense to do it. Obviously, just want to run the analysis on what you're getting with that benefit.
Great, thanks. How was CR determined for the secondary windows? We had a couple of questions on that, given that you're basing it on the primary window, existing primary window.
Yep. Again, the CRI, this is the calculated or estimated number. People who are familiar with the CRI, it's ranging from 0 to 100. It's this kind of scale. And from this, from our study, from the existing single pane, the CR that we get from this window only 12. So very, very prone to condensations that could happen. But I don't know if it's already happened or not, but one thing about it is we in Colorado, it's pretty dry climate. So I don't get any report about that if during our study, the existing have any condensation. So again, once like we put together in the model, this is the calculated. So the existing single pane and one is combined, it's significantly improved and up to almost like 50 CR. And
when we're talking about condensation, were there any issues with condensation between the pre-existing window and the storm inserts?
Like I mentioned, the air gap between that, it's very, very small. So I don't expect that you're gonna get a lot of moisture build up between panes. That's once like the cold surface temperature of the existing will going below dew point, and then you start getting a lot of moistures build up, become ice and those kind of things, because the gap is very, very small. So once like you put it in there, I would expect less problem or none of this problem.
Do we see an issue with any in the appearance of these? It's being problematic for historic properties.
That's a good question. For the historic properties, as we all know, number one is there's a restriction on any changes from the outside. From the inside, sometimes it's some the restriction also. But again, this is like this is removable for this building. So it still maintain the aesthetics, everything for the historic. If you remove it, if everything is going back to the original, it's almost nothing. But during occupy or from time to time, if the building happen to have occupants, not just only the buildings that's empty. Of course, like, adding this will significantly improve the thermal performance.
I think you may have answered this, but it's come up a couple of times, so maybe it's worth asking again. Is this technology only applicable for cold climates, and can we apply it in hotter climates? And if so, does that mean it would make the space cooler?
Yes. So because of the wide application of these technologies, so it can be applied to both warmer climate and cold climate. Cold climate, definitely we recommended a better performance like the double pane secondary, and then the warmer climate, the single pane might work really, really well with the solar control. So the answer is like, yes, it would work for our climate zones with the customized, solar control, solar heating coefficient.
Great, thank you. Is there any application for these windows for multifamily high-rise buildings?
That's a good question. Right now, as far as I know, that the applications work very well with the punch window. When we talk about high-rise, sometimes we talk about like, curtain wall or those kind of thing. But one point that I want to make it out, even window in the larger side, when Tyler mentioned that maybe that larger side, we can divide this window. It happened to building 53 also. The building is pretty wide, so we end up making as a 2 panel instead of a single panel in one window. So the application for curtain wall, we have to probably talk with the manufacturer if that kind of application. But in general, punch windows, and then either whether it's going to be high rise or low rise should be applicable.
Great. So for warm climates, do we know how the economics of these windows would compare to applying window film?
Good question. I think the cost, I don't have the data of the cost of the films. I would expect that probably very, very competitive between this technology. Of course, it sounds like, applying the films seems like it's very, very easy, but with this adding, improving U factor, U values, you also getting a lot of heat loss or reductions, through reduced conductive heat transfer as well. So I don't have a number on top of my head, but that's a good question.
And finally, are the secondary windows commercially available? Come up a couple of times.
Yes. As far as I know, it's commercially available, but commercially available means like through manufacturers, and then it's not like on the shelf in a big box store. It's already available. It's commercially available for both single and double pane. Yeah.
Great. Well, thank you all. And so we have 1 minute left. Thanks for all those great questions, and we'll follow up with all of the questions that we didn't get to and some more detailed answers in an email. I think as mentioned, this webinar is available you can get continuing education learning units through AIA, and for GSA attendees, you're also eligible for continuous learning points. So you'll receive a survey, and by completing that survey, you can request credit. So thanks to all of our panelists and to everyone for attending. Great job, and we're looking forward to seeing you on our next webinar.